Good morning, guests, faculty members, and students. A very warm welcome to everyone joining us today. I'm Pasapan Chanwasunan from Faculty of Architecture. I'm the MC of the event today. We are gathered here for Architectural and Design for Society Academic Year 2025. This monthly academic lecture series serves as a platform where we host national and international guests from various disciplines. Our goal is to share profound knowledge, fresh perspective, and professional experiences in design and research. Specially focusing on projects that address social issues and provide meaningful benefits to our community. For our professional attendees, you can earn CPD points by attending each session. Participants who attend more than 80% of the total lectures in this semester will receive an official certificate of completion. These hours can be accumulated in credit bank, which may be used for credit transfers if you are enrolled in the future program here at Faculty of Architecture, Chulalongkorn University. This event would not be possible without the support of our partners. The Faculty of Architecture, Chulalongkorn University would like to express our sincere gratitude to Skunthai Company Limited for sponsoring this activity. To officially commence today's event, I would like to invite Associate Professor Dr. Warisha Wongpayat, Associate Dean, to deliver the opening remarks and a message of appreciation to our guest speaker. Please welcome.
Good evening, everyone, and warm welcome to the Architecture and Design for Society lecture series here at the Faculty of Architecture, Chulalongkorn University. On behalf of the faculty, it is my pleasure to welcome our distinguished guest, Professor Ichinose Masayuki from Tokyo Metropolitan University, who has been here with us since last April, thanks to Professor Bandit Julasai. His visit marks an important collaboration between Tokyo Metropolitan University and Chulalongkorn University, fostering international exchange and shared inquiry into sustainability and the future of architectural discourse. And this evening lectures entitled Building Performance Metrics, How Much Your Architecture Extend That Collaboration into the Public Sphere. Through his lecture, we will explore key issues, including the factors that determine the value of a building and their potential applications, as well as how high-performance building can contribute to the sustainability and of our built environment. Before we begin, I would like to thank you, Ajahn Pasapan, for kindly serving as our today MC, and thank you everyone for joining us. Now, please join me in welcoming Professor Ichinose.
Okay, before we start, let me introduce our speaker today. Professor Masayuki Ichinose is a full professor and the head of the Building Environmental Engineering Laboratory at Tokyo Metropolitan University, Japan. He earned his Ph.D. from Tokyo Metropolitan University also, and currently serves as a visiting professor at our faculty. Professor Ichinose is currently leading a research project to zero energy buildings tailored to the Asian climates and culture, supported by the government of Tokyo Metropolitan. In addition, his expertise, academic publications, he is a prominent figure in the professional sector also. Currently, he is serving as the president of the ASHRAE Japan chapter 2024 to 2025. Please give a warm welcome to Professor Ichinose.
Thank you very much for kind introduction, and it's my great pleasure to be here today. And thank you very much. Also, thank you very much for coming to my lecture for all audience. So my name is Masayuki Ichinose from Tokyo Metropolitan University. My department is architecture and building engineering. So actually my area is more building engineering side, but today I will try to something talking about design aspect also. Yeah. So I don't need to talk about myself already. Ajahn Max introduce myself. And yeah, this year I stay here for whole 1 year as a visiting professor and doing some research project in Bangkok. Then I will go back to Japan in beginning of April. So first of all, I'm talking about my university, Tokyo Metropolitan University. This university is organized by Tokyo Metropolitan government. And scale of the student is 20% of Chura, so not so big university. But I'm not sure about budget, but our university is supported by huge government. So we have a lot of budget for research and education. This is my laboratory. In Japan, if you become an associate professor or professor, we will organize our own laboratory. Currently, I have 20 students for master and undergraduate and Ph.D. For Ph.D., mainly I accept from overseas. I already have a graduate of Chura for five students. Yeah. They are now already finished a Ph.D. course and working here, some university or companies. So this is my research laboratory research theme. So our research target is building performance metrics. Today I'm talking about. Then our research topic divided into mainly 4 topics. The first one is facility management and commissioning. It's kind of after built performance evaluation. Second topic is facade engineering. It's related to my PhD thesis. Third topic is zero energy building technology for tropic climates. So that is why I often come to Thailand, Singapore, Vietnam to realize and thinking about fit to this climate, hot and humid. Fourth topic is kind of human health area, but it's not my area. It's related to my assistant professor area. Today I'm mainly talking about these 3 topics. So this is today's topic, what I am talking today. First topic is my research background. This is why I'm focusing on building performance metrics. Second topic is itself, today's thesis, and followed by artificial intelligence. It's something new area and discussion. So when I was master and PhD students, I was focusing on the building envelope performance. You can see there a lot of building in Bangkok and has super high-rise and grazing, and mainly I was studying about these matters. So it's related to daylighting utilization and solar heat gain and shielding, and this solar radiation is going to outside, where to go, I was discussing. And this research going to simulation and modeling. And nowadays, it's very common technology, but that moment, little bit newer topics. It's related to energy simulation and daylighting simulation at the same time, and some spectral radiation, something like that. So simply say, my research focal point is how to fit to the solar radiation energy. Because you can see the outside, solar radiation is coming. Today it's very hot because solar radiation is super big power. Almost the energy amount is 174 petawatt. Petawatt is like a peta is this kind of level. So simply say, this is 10,000 times of our human being consumption of the energy at this moment, every moment. So it is very big power. That's why our Earth is controlled by temperature like this. So when it comes to the building and urban area, so this heat balance is quite important. Solar radiation is coming to the surface of the Bangkok. Then some energy is going to reflect. Some of the energy go inside the building and release to the atmosphere. Then this kind of cloud is coming. Solar, this kind of is related to the vaporization. And sometimes rain is coming, evaporate, and everything is balanced. But for example, in Bangkok, this balance is already collapsed. That's why every year temperature is going up. So this is so-called urban heat island. Yeah. So because of the building, so this happened. So you can see the solar radiation is coming to the building. Sometimes reflection, but almost all the solar energy is going to be inside of the building. So that's why we need to the air conditioner, especially in Bangkok, right? At that moment, I just study like a more detailed numerical modeling and simulation methodology and something like that. But I don't talk so much. But so this kind of modeling can apply to this kind of big scale numerical simulation and building scale simulation at the same time. So because of this kind of the background, after PhD, I started collaboration research with Sony chemical devices. Why Sony? It's coming to building material. Maybe you're a guess, right? So this time, at that moment, Sony suggested me to do this research. So solar radiation is coming to the building facade. So they suggested to this kind of retroreflection mechanics. You know, this retroreflection is very common. You can see some of the road sign or tail lamp of the car. Everywhere you can see. But reflector is this kind of mathematics mechanism is working. So that means some of the light or radiation is coming and reflect to the same way. So this is called retroreflection. What Sony suggested is this technology is going to be applied to the transparent building facade. Because Sony has technology for techniques to make a structure of transparent and thin film to make any kind of the multiple functions. You know, 30 years ago, LCD display has, if we see the little bit different angle, it's like a darkness, cannot see anything. So Sony and some Sharp or this kind of manufacturer has this kind of microstructure technology. So Sony suggested me to do this kind of technology to apply to the building material. Then solar radiation is coming to this thin film. It's just a 20 micrometer. Then they reflect to the same way. That means solar radiation is coming to building and go up to the solar direction to the solar again. Right? So it can be avoided to the urban heat island and energy conservation. Everything is solved. So normally the normal window technology is accept the visible sunlight to the inside because we need light inside space, right? But we don't need solar heat. Then reflection to happen to the outside. This is called near-infrared solar radiation. It's invisible for human eyes. It accounts for 40% of solar energy. But this technology can reflect this near-infrared to the sky, direction to the sky. Right? Very simple and very good technology, I think. So at that moment, I just do some very scientific approach to verify and prove this technology is very efficient for any kind of building, energy conservation and urban heat island. Then go to some Q1 journal paper, and it was very good achievement for me. So simply, I just illustrate here. Normal buildings, solar radiation is coming to the building facade, and performance was not good. So solar radiation is coming inside. Needed to air condition a lot and heat exhaust to the outside. And energy consumption is very big. Then next step, if you apply high performance facade to the building envelope, but solar radiation is going outside. So as a result, urban heat island cannot be solved. So this technology achieves everything, right? Energy conservation and urban heat island mitigation and sustainability, everything. So because of this achievement, I was on TV talking about how the building envelope is important and what is the secondary effect of the high performance facade, something like that. Yeah. I was also invited to some big conference for the advanced scientist workshop at Lawrence Berkeley National Laboratory, one of the best research institutes in US. I was also invited to National University of Singapore to talk about this research achievement and started to collaboration about research. So finally, my research achievement is going to be commercially available. Yeah. The product name is Albedo. Its technical word is albedo. Albedo means reflectivity of the urban surface. Right? So this product can enhance total city reflectivity because better reflection. Right? I believe that my life is going to be sabai because I must get big money from patent of Sony. Right? But actually it's not. It's wrong. Because this product just sells only 1 or 2 projects in Tokyo, then finished. Can you answer why? Huh? Why? Can you ask? Can you answer? Why? No. Because this is just a window film. Okay. So answer is very clear. Nobody will pay for invisible technology because infrared radiation, right, cannot see. And how much I'm talking about urban heat island effect, sustainability, it's also invisible, right? So finally building owner said, oh, cannot pay, finish. So the lesson, good technology doesn't have to improve sustainability, right? Even good technology, good products, doesn't make sense. Because without marketing, this is not my responsibility, Sony's responsibility, right? They don't have any strategy for selling. So I understand, or visualization or performance is quite important to communicate with market. Because if we don't have market, our research doesn't make sense because our area is architecture, right? So this is lesson. So when I was young, I'm still young, but I believe that good science technology improves sustainability, right? And I focused on scientific research for journal paper achievement because I wanted to be big professor, right? But because of this lesson, I changed my mind, right? I thought I changed. So I focus on actual building projects rather than simulation or experimental scientific research at all. I stopped. So because I became professor, I'm more focusing on with students what we can do. So I'm focusing on the actual building projects. It's related to building performance metrics because for students, this kind of actual project is best education. We are university. Even if students something fail, it's okay. Yeah, no risk. Student can challenge. Right? So this is my changing after this lesson. So that's why I'm focusing on building performance metrics. So what is building performance metrics and why? Simply say, it's kind of the evaluation method for building performance and value, right? So I can explain the main reason why we need to these metrics. First of all, in terms of sustainability and human health, because nobody knows how much this building affects sustainability and human health. We are now here, we are using electricity, but how much this activity affects to the sustainability? Nobody knows, right? And how about air quality? Right? Nobody knows because there is no index. If we have transparent framework to visualize how much we are now consuming energy and how much GHG is exhausted, how is the indoor air quality right now, how much risk is, so people can understand and we can choose build environment ourselves, right? Okay, if you work somewhere, library or your workspace, this place is not sustainable, I will change to other place because we can identify, right? Yeah. The other aspect is economy, because our building sector is quite related to economy. Yeah. Because right now, no evidence for index of evaluating building value or sustainability. So nobody can invest for good building, right? If you're a business owner, even if designer say, oh, this sustainable design works for CSR, ESG, but no resources, no evidence, building owner cannot invest because stakeholder don't allow, right? Cannot explain to stakeholder. So the reason why we need metrics. Also, transparent framework enable fair charge or taxes for environmental road because we need to go to carbon neutrality right now, right? So some government try to do the carbon tax, but right now it's still insufficient evidence and any kind of the value or metrics. This is very big problem. For example, Japan, actually Thailand also already declared to carbon neutrality 2050, right? So it's same as Japan. We have to achieve together, right? But in Japan, we already declared that we plan a lot of things. From 2018 situation, we need to reduce 80%. 80%. That means we have to zero energy, everything at all. Because in Japan, building sector occupies 70%, right? I don't know statistics of Thailand, but maybe similar amount. That means by 2050, all of the Thai buildings should be zero energy building, including this building, your house, right? Can you imagine? Yeah. Actually, in Japan, I already thinking about impossible. Cannot. I don't have to say loudly, but I think impossible. Yeah. So, by the way, so what is the difference from other products, our architecture? Basically, our product is immovable. Once we put it here, cannot move, right? And huge cost and huge environmental load, a lot. And long period for design and construction. Normally takes half a year. Some big projects need 5 years and more. Normally sales contact without real products, right? And long lifetime and operation cost is very huge. You can see this graph. So this is very fundamental of the education for facility management. Yeah. Maybe somebody already see this graph. This each square represents the amount of the cost in each stage, design and construction, after build operation. So you can see there how much operation cost is big rather than design and construction, right? And long term. But we also have to know about our building produce a lot of money after built rather than this kind of cost. Can you imagine the super high-rise building around here, Siam? For example, when it comes to office buildings, they produce a lot of money every day, every time, right? Then it's going to be 30 years, 40 years. So the amount of money is totally huge amount, right? Even hotels and some hospital also like that. So somehow we are also responsible for this kind of cost, right? So we need to change our point of view, not only here. Because of this, we call OM, operation and maintenance, the importance. That means we need to do the continuous quality control. Normal products, smartphone or some cars, normally just taking care production stage, right? quality control, right? Once sales, it's just a bye-bye, right? But buildings cannot be like that because of this, right? So that means we need to have data collection and analysis continuously, long term. Cannot stop. This is kind of the evidence-based management, right? It's very normal way of thinking for the engineering management. But building have to do continuously, long term, cannot stop. This is one of the big characteristics. So, about data analysis, nowadays everybody say machine learning, AI utilization, and big data analysis, but our area is not easy. Can you imagine, for example, if we visit some data buildings, or building data management, or let's see the data, the format, and data reliability, and everything is different, each building. Right? For example, our research team go to some building. First of all, we have to see the building, building specification documents to see what kind of document they have. So we have to analyze documents. Okay, let's go to data. Or what kind of data is it? So everything has to do by human being. It's very tough work. So that's why we need to go to the more integrated data solutions by utilizing IT technology. So one of the important topic right now for our team. So this is my research goal. Simply say, I wanted to build digital twin. So here is a real building. I just put digital twin inside computer. Then all of the building information is going to be computer. Right? This is my image, but it's not the easy way. So today I'm talking about case study as shown here. Somehow we try to do some IoT technology or some information technology, how to go to the building performance metrics. This is name is Blue Front Shibaura. So this building located Bayside of Tokyo. You can see the very great sightsee, great view. Yeah. And the building is like twin towers. The scale is 150,000 meters square. One of the biggest scale of Tokyo office building complex. So this is Nomura real estate project. For this project, I was invited to this project 2020 during COVID. So Shimizu Corporation, the constructor of this project, invited me to talking about how to enhance this facade performance by utilizing IoT technology or something like that. Because design is already fixed by famous architects, we cannot discuss design at all. We just, I cannot discuss about inside building. So what I contribute is like IoT control for air conditioning system and lighting and shading devices. Everything is utilizing new technology. For example, you can see here, it's kind of the motion sensor on the ceiling. This is kind of the image sensor. So this is example of the detection of the inside the space. This kind of sensor can identify the number of the human in the space and the activity of the human. For example, I suggested gesture control. If the human gesture like that, okay, shading device is going to shade it on the facade. If the human behave like that, okay, AC set point is going to down, right? Like that. But actually in the real project, most of my idea is cut it because of the cost down. But we can try some of the new things. For example, we tried some physiology sensor application to evaluate human satisfaction in the office space. Maybe some of the audience have smartwatch, right? Then you can see your health condition by application, right? So we just apply this technology to analyze some human heart rate, surface temperature, to analyze human conditions by ourselves. If you have Apple Watch, we cannot see inside of the data because of the ethic issues. Yeah, cannot. We just utilize some other special devices to analyze this kind of data. Nowadays, we can also utilize this kind of ring data. Yeah. It's more easier to identify. Yeah. Amazing is we just apply some machine learning, and the result of the analysis, we can identify big correlation between human thermal sensation and comfort. That means we don't need to questionnaire survey anymore. You just put ring or wristwatch, then we can see how much human being satisfied, complain, comfort, or your work performance is good or not. Everything can be identified. We also try to do in this project, using this kind of motion image sensor on the laptop. It's very difficult to this kind of research, but I discussed with normal real estate company to the meaning of this research, and they allow us to do this research. So this is utilizing the AI technology to identify from this motion image to vector data, how your face is moving, or your eyes blinking, or your eye direction is going somewhere. So everything goes to the vector data. Then we can analyze numerically. As a result of our research activity, so we can identify also big, important results. So if we have this kind of motion data, we can identify some of your tiredness or your condition of the body. We can know about this. Maybe in the near future, your work performance always observed by your business owner, right? Oh, can you imagine? But still on the way. Right? So we also try to before and after moving office comparison. Because this is normal real estate headquarter project. In the past, last year, normal real estate headquarter was in central Shinjuku. Then last year, they moved to Shibaura. That means we can compare directly before and after. So this is a big company. Because of the discussion with normal real estate company, they allow us to the 1,200 subjects for the questionnaire survey. Yeah. It's very big number. Yeah. It's very different. Right? This is before moving. Old office looks like very conventional Japanese office, very hierarchical, and small window and old-fashioned. But right now, it's very great office. is like a very new fashion, right? Active-based working space, lighting, air conditioning, everything is IoT controlled. If you see it outside, you can see the Tokyo Bay. Oh, very great office. So actually, they just moved to new office. We just have old office data right now, but we can evaluate some of the economic level. I don't talk detail, but this is very big impact result we already have. Because of the old office space, actually air conditioning control, lighting control is not so good. Air quality also not good. This result shows that because of this kind of inappropriate condition, how much affect to the workers' performance converted to the money, right? Of course, there is a lot of definition and hypothesis, but anyway, we just calculate. Because if we don't clarify the economic impact, normal people don't understand, right? So result is very amazing. Because of this old office situation, in each employee has economic loss has 224,000 Thai bahts per year. Right? In Japanese yen, 100万yen every year. Because normal real estate has big salary, but 100万yen is very big impact, I think. Also, if it comes to company level, it's gonna be 286 million Thai bahts. Oh, it's very big. So let's see, after move to the new office, maybe this loss, economic loss is going to be shrink, right? I hope it's going to be zero, right? So that means this investment has meaning, right? Company can explain to stakeholder this investment is meaningful, right? So let's see the result. Maybe next year I can talk about this result. So in the second part, I'm talking about building performance metrics. Why it's needed, why it's necessary. Because building need continuous evidence-based management for long term, right? It's totally different from any other kind of industrial products, right? And building performance metrics makes people to understand and choose their own environments. Because right now we have no information at all. We can choose if we have information. My idea is going to be some smartphone or Instagram or TikTok, anything okay. But I wanted to set up a transparent metric system in the future. So yeah, transparency is quite important. Emerging data means not utilized data. For example, smartphone or your smartwatch or smart rings can utilize a lot of potential. Yeah. So I just showed a case study this moment, and this has big impact, right? Yeah. Maybe it's going to be over, okay? So next chapter is artificial intelligence. I already talked about some utilization of machine learning and artificial intelligence for my research work. But this is my homework given my Ajahn Bandit. Right? Nowadays, young students asking everything to Chappy. Right? I just call Ajahn Chappy. Because this to answer to your any kind of questions, right? Of course, I always sometimes use this Chappy. Yeah. They also create any kind of image, documents, some of your homework, right? As you want. But be careful. Sometimes this one still answer generate wrongly related to undefined area, right? Because of my experience, sometimes I ask some my matters related to research or scientific matters, they easily answer wrongly, right? Because data is not enough. I'm not sure in the future, but still on the way. That means we still need to have ability for judgment, right? That's why students have to learn. Because AI still not judge. Yeah. We also have to have ability for imagination. Right? Chappy don't imagine. They just follow your request. Right? This is matter. If you ask Chappy to purpose your life, it's going to be matter. Don't ask about this kind of things, right? Okay. So, what is human is superior to AI? I see some books or information, but maybe this answer is more understandable for me. So I just refer to Mr. Bob Stanfield's very famous CEO for McKinsey and Company. Because this company, one of the biggest company to utilize AI for their business at all. So he said 3 things what humans still do that. The first one is ability to set ambitions, because computer doesn't have ambitions. They don't have purpose. They don't have goal, questions. Only we can give question to them. The second thing is ability to make judgments. Because computer cannot judge. Then also creativity, right? Create. Because they don't create anything at all. Yeah. They just show the result of their past data or evidences. Right? Okay, so when it comes to architecture, just my idea here. AI occupy architectural design work? I think yes, to some extent. Because they run a lot of past drawing, photos, maybe normal buildings, we don't have opportunity to design anymore in the, I don't know, few years later. What we need to do, architecture as an object is not our target anymore, maybe. If you're just thinking about design methodology or object architecture itself, maybe AI do that. But we still have to do design and create experience of the human, right? Because AI cannot imagine. They don't have experiences. We have experiences, right? So anyway, we still need to run architecture because we have to judge, right? So what we have to study at university is just my idea here. three things I have concluded here. But I'm not sure it's true or not. This is just my idea. The first thing is creation. Because your own discipline allows creation. If you don't have discipline, cannot create. Second thing is realization. Your own knowledge or technology or material or design methodology or allow realization. Right? And final thing is experiences. You must visit a lot of architecture, good architecture, any kind of places. Then you can own experience improve discipline and knowledge. Right? So this is my answer. I'm not sure it fits to your question. Yeah. So I have these three hypotheses. I just try to fit to my my project, my own project. This is case study 2. Actually, this is my house in Tokyo. So this is concept of zero energy house and how to design and how to improve energy performance at the same time. During COVID, I have nothing to do, so I try to a lot of study in my house. Yeah, then design is like that. So the location is very like a slant hill. Right? That means the view is very good. But we have some risks for the earthquake because we have big earthquake. We have to thinking about seismic design at the same time. But fortunately, we have some kind of public park near this site, right? So we can utilize this kind of natural resources and location. So I just design like that to the structure is like a concrete. And upper structure is wooden structure to integrate with a natural environment, like that. Then the performance is zero energy. So this is kind of integration design. Do it myself. Actually, I'm not a registered architect. I ask my friends to shop the house drawing. Yeah. So this is my expert's knowledge to apply to design. So basically, I just apply some kind of the passive design to enhance natural ventilation, and my facade knowledge to enhance solar shading performance and something like that. Also, I apply some kind of the photovoltaic power and convert it to the smart energy control. And I also apply some natural water resources in case of the emergency, because we will have earthquake soon later. So this house can survive detached. Right? Yeah. We don't need energy and water infrastructure. So finally, I would like to introduce my as I show 3 concepts into this my house project in the movie. No audio is coming. Let me see. No. Okay, but it's too large, I think. Okay. It's 4 minutes. Well done. So I just would like to finalize my presentation. And today I'm talking about building performance metrics. And some of the, I just explain about characteristic of building, why we need continuous evidence-based management, right? Because building is long term, and the scale of the economics is very high after built, right? And also explain about potential of emerging data utilization. It's kind of AI utilization for building management and metrics. So finally, I just discussing about cooperation with AI, how our university and students, professor cooperate with AI. Yeah, just my idea. So the one is creation. The second is realization. The third is experiences. Right? So I hope this my lecture it's going to be understandable for you. So thank you very much for your kind attention. I really appreciate Ajahn Bandit to accept my stay here. Hook up.
Okay, thank you very much, Professor, for the very informative presentation. After this, I would like to open the Q&A session. Any questions from the floor?
My question is, your house very effective for the energy. How do you think how you manage the aged people to use your house effectively? Thank you.
Okay. Actually, my house in the operation is not zero energy because, for example, my kid, high school kids, he consume a lot of energy for air conditioning and TV game all night. So actually, it's not zero energy. This is problem, but yeah. But design is concept for zero energy.
Okay, and the good things that I've seen from the design is the stack ventilation, which is a very good idea for tropical design for the house. I quite appreciate on this design.
Okay. Thank you very much. So, because nowadays in Tokyo, when it comes to summer, it's hotter than Bangkok. So I really thinking about during summer season. That's why I apply wooden surface material, because wood itself is super strong insulation. Yeah. So the reason why I apply this kind of design to the upper structure. Yeah. Thank you very much.
Thank you so much, Professor Ichinose, for sharing with us your lifelong research and your insight and about your project-based research and how we cope with or how we co-design with the AI. I have a question that continue with the first person that asked you. Thanks for sharing with us your lovely house. It's very I would like to visit someday, if possible.
Yeah.
So my curiosity is, have you used smart watch or smart ring to detect or gather the data when you reside in your own house, or you plan to?
Good questions. The problem is nobody cooperates this kind of activity. Nobody allowed to bring some research devices inside my house. Right? Only me. So, yeah, I cannot do the after-built survey for my own house. Only the other people's buildings. So, yeah, this is problem.
Okay, thank you.
I'm sorry about this.
มีคำถามไหมครับ
So while we are waiting for another questions to come, I have a question about the section of the house that it seems your house is 2 story above the ground and 1 story under the ground. So
Yep.
can you maybe elaborate more about the underground function of the solar heat water tank for us and our students? So what is
Okay.
used?
So normally people know about photovoltaic on the roof, right? But in Japan, the most energy usage is hot water because we take a bath, we take shower every day. So almost 30 to 40% of energy is used for hot water. So I apply the solar heat collector. It's just water is going to the rooftop and heated by the solar radiation and coming to here, storage. Then if you use the hot water, it's going to be supplied like that. So the 30% of my energy is reduced. So that's why I apply this one. So I also utilize this water to floor heating because the basement is during winter is very chilled. So this hot water utilized for the floor heating during winter. So in Tokyo, we also have to thinking about winter season and hot water. So that's why.
Thank you.
มีใครอยากถามอีกไหมครับ Okay, for me, one question. For the Nomura building, how long does it take in order to get the break even?
About
Break even point.
great.
Break even. How long? In order to get the payback for the investment money.
Oh,
Do you know that?
okay. So I cannot say clearly right now because this data is still before moving. This year we plan to do this survey in new office, same things, same way, same target. Maybe we can clarify about human resources. Right. Energy and other maintenance we can calculate. Yeah. Maybe this one is much more strong impact, I think. Yeah. So cannot clarify right now. Yeah.
Okay, if no question from the floor, I would like to thank you again, Professor, for the informative presentation. It's very good for us to know that in order to be the net zero energy in the future. Okay. And thank you very much again, Professor. Okay. For the next lecture series, it will be the storytelling with light and interpretation of contemporary Thai by Assistant Professor Wannapa Pimviriyakul from the With Light Company Limited. Okay, on Wednesday, 11 March, and at this time. And please stay tuned for the knowledge management of the lecture series. You can access through our website and the faculty YouTube channel. And after this, please evaluate our lecture series through the QR code. Okay, and you can grab the snack box at the lower floor. Thank you very much for coming today. Thank you.